Alright, hi everyone, how are you all doing? So today we have another Codeforces round and it is Codeforces round 735, Div2. So yeah, I'll be participating in this one. And let me just see if everything's fine. Yeah. So yeah, the goal here would be to save candidate master again. I mean, even if I perform normally, I don't think I should lose candidate master, but in case I perform, very bad, then I might. And obviously I don't think I can become master right now, like even if I perform really well, because that would require like a positive 130 delta. So yeah, not aiming for that right now. And let me put this on silent. Yeah. Okay, then let's begin. 3, 2, 1, go. Okay, problem A. You're given n integers. Find the maximum value of max of into minimum of this over all pairs of L R. Okay. Okay. Then R has to be greater than L. Okay. We have to choose at least 2 elements. That is the thing here. So if I consider a longer segment, let's say I have picked 2 elements. If I consider a longer segment, then there are chances that my maximum element increases, right? Okay. 4 into 2, 4 into 3 we can also have. Okay, let's consider the maximum element here. I have to choose at least one more element. That is the whole point here. And if I choose 3 elements, let's say I'm only concerned about the first 2, then I should pick up the first 2. If I'm concerned about the second and third, I should pick them up instead of picking all 3. And if I'm concerned about 1 and 3, so the thing here is that I will only be choosing 1 and 3 if 1 is the maximum and 3 is the second maximum. But if 3 is the second maximum and the middle one is lesser, then obviously I cannot choose them, right? Okay. So if I just pick up one element, like let's say I pick up the maximum element and I sort of decide to move forward, considering this to be the maximum element, then the minimum element that I pick up will always decrease if I increase the length of the array. I mean the length of the portion that I've chosen. So yeah, I think I can just iterate on all these pairs, like right, so this just means that if I'm iterating, I mean if I'm on the ith index, then I have chosen this to be the maximum element. Okay. And can these values be negative as well? Okay, they cannot. So if I is greater than 0 and ARR at I minus 1 is less than I, okay, so why am I doing it like this? Like I can just do it for all adjacent pairs. 12, 6, 4, 6. Yeah, this seems to be fine. Okay. $439. Okay, let's read problem B till n. You're given n integers a1, a2, so on up till an, and an integer k. Find the maximum value of I into j minus k, or ai. Okay, into ai or aj. Over all pairs of ij. Okay, I don't know what is the issue here. Like, it is taking a hell lot of time. Okay, let's just not think about this. So we have to find out the maximum value. Okay, I into j minus k times ai or aj. Okay, and ai's are also less than equal to n. Okay, I into j minus k times ai or aj. So I basically want ai or aj to be as less as possible, right? Yeah. Why is it still in queue? So these have been evaluated, but some of the solutions are still in queue. Like, I don't understand what is the issue here. Okay. Minus k times ai or aj. I want ai or aj to be as less as possible. right? And I into j. Okay, so in case I have a 0 here, I mean the AI value itself is 0, then I know that if I take the OR of 0 with anything, it will be 0. Okay. I don't know what is happening. So this solution got evaluated, like this was submitted at 6 minutes and this solution is not. This is just insane. Okay. Should I raise a query here? I don't know. So that just wastes a lot of time for me, right? But this queue is like, I don't know, it is strange. Solutions submitted at 8 minutes, 6 minutes are getting evaluated, but not the solution submitted at 4 minutes. Okay. I into j minus k times AI or AJ. We want to maximize this value. Okay, I want to maximize AI, I mean I into j. So I should, in order to maximize that, I can just pick up the last two elements, right? Yeah. Or rather, I should consider it like this, that if I am on the ith index and I need to pick up another element left to the I, right? Left of I. Very good. This is insane. Okay, let's look at the sample test cases here. I times j minus k into ai or aj. Zero up till n. So even if k is 1, let's say, okay, so if I'm able to find a 0 in this whole array, I should pick up that 0 which has the index maximum, right? Like that is just one thing. Yeah. And let's say I want to make an OR value of 1. Then what would be required? Okay, here it is OR, it is not AND. Okay. It is not, yeah. I was considering it to be AND the whole time, so it is OR basically here. So if you consider AI or AJ, then this value will always increase. Like you can take it with any element and this value will definitely increase. Right. Okay, if I talk about AI or AJ, then I already know that my answer is, let's say, I times J minus K times AI. Right, it is actually this minus K times AI plus K times AI XOR AJ. Not XOR actually. Let me think. Okay. So I think we don't need to consider all pairs here. Like if we just look at this case, yeah, let's say n equals to something like 100. Let's choose a different color. Yeah, let's say n equals to 100. Okay. So if I just pick up the last two elements, so it would be something like 100 times 99. Right, this is already 9900. And if I choose the other two elements, let's say 99 times 98, and if I subtract them, let's say, then this would be 99 times 2. Right. So if I go from here to here, I am already subtracting this huge number. And what is this huge number? This is 198. So even if I, even if I consider that value AI or AJ, that can be at max n, right? So that can at max be 100. So I don't see any advantage in taking up this. I don't know. If we can consider the last k values, I think it should be fine. Let's see. I mean, that is just an intuition. I don't have a proof here. The idea here is that, if I keep going towards the left, like if I keep taking up lesser elements in terms of their index, then yeah, the amount that I'm losing here is, it is too much. Because AI or AJ can be at max n. So if I consider k times AI or AJ, it can be 100 times, n. Right, it can be at max 100 times n. So even if I consider this n times n minus 1, and let's say I am getting a value of minus 100 times n. So if I consider lower values like n times, or let's say n minus 1 times n minus 2, then I'm already losing n minus 1 times 2 here from my answer. Right, so why shouldn't I just consider the last 100 values here? I think that should be fine. Or I can even do it for 200. I mean, that is not at all an issue. Yeah. And what is the time limit here? Time limit is 1 second. Okay. So why am I getting -3 here? -1, okay. Okay, this was I plus 1, right? I mean, that is fine. Okay, this should be fine. 10,000 test cases, and I have like this can TLE. Sum is up till 10 to the power 5. No, this should, then this should be fine. Okay, cool. I don't know if there is some other solution to this problem. Let's just log this. And let me also look at the time taken. 77 milliseconds. I think it should be fine. Okay, let's look at problem C then. You're given two integers n and m. Find the max of the sequence n XOR 0, n XOR 1, so on up till n XOR m. Okay. Max of the sequence of non-negative integers is the smallest. That doesn't appear in the sequence. Okay. We have to find the smallest non-negative integer that does not occur here. So n XOR 0 is what? It is n, right? So when will this be 0? Okay, if we talk about the very brute force solution here, so there are basically m terms here, right? So the XOR has to be less than equal to m. Right, if you have m elements, then the XOR is always less than equal to m in that case. Right. n XOR I is less than equal to m is greater than m. I mean, this is what has to be done here. This is just the brute force. Yeah. So we have to find the first number that does not occur here. Or in other words, we need to find x, the smallest x, such that n XOR x is greater than m. Smallest number that doesn't occur here. So obviously the max is less than equal to m. That is for sure, because there are only m terms here. Okay, when we say that we want the max to be 0, the condition here is that n XOR 0 should be greater than m. Right. And n XOR 0 will be greater than m when m is greater than n, right? Yeah. So this is one condition, like this is the trivial case here. So this is the brute force. Now here, if n is greater than m, then I for sure know that the answer is 0, because n XOR 0 will be greater than m. So I have to find the smallest number such that I take the XOR of n with that number, and the answer that comes out to be that is greater than m. Okay. Can I also look at the wrong solutions? No, I cannot. Okay, maybe we have to do something with the bits here. So we want n XOR x to be greater than m. Okay. So if I consider these numbers, like if I just go from n to n, right, let's do this. One, okay. If I do 1000 XOR 1, that will be greater than 1000. Right. Okay. Or if I do 7 and 7, then the answer should be 8, right? Yeah. So if all the bits are set in n and m, right, okay. Okay. So if we look at this, what we want is, we want this n n's or x to be greater than m, and what you want is x minimum, right? So clearly, like, let's say we consider the bits, okay? Let's say n has 1 and m has 1 on the most significant bit. So if we talk about x, it cannot have 1, because if it has 1, then obviously the whole value would be less than m, right? So in this case, x has to be 1. If n is 0, and sorry, this has to be 0 here, and m is, let's say, 1, okay, then x has to be 1 again, right? Now let's say I decide that n is 1 and m is, let's say, m is 0, okay? So if I somehow put let's say put a 1 in this bit, then I know that my overall answer will be greater than m, right? So here, if I can put x as 0, if I put x as 0, then I'm done. Otherwise I have two possibilities here. Like, I can just go on. By putting x as 1, I can just go on. But why would I do that? Like, that's not necessary here, right? And if n is 0, m is again 0. Here I have two choices. Like, either I can put a 1, yeah. So if I put a 1, the overall value becomes 1 here. But it might be that I put a 0 here and I later get that value, right? So I just need to consider the bits here. So I mean, I can consider it from 31 and go from all the way up till 0. Right, or I can consider it from 32. It does not change my answer. Right. So first of all, I have to check the bits. And then right. So if bit 2 equals to 1, then I cannot do anything here, right? I just have to do prev. Okay, but if bit 2 is 0, then I can do something, right? So if bit 2 is equal to 1, if bit 1, okay, is greater than 0, basically. If bit 1 is greater than 0, I don't have to do anything. But if bit 1 equals to 0, then I have to do prev equals to prev or bit 1, right? Similarly, if bit 1 equals to 0, then I can do answer equals to min of answer comma prev or bit 1. If I do this, then I'm done, right? Yeah. Else So if it is 0, then I can do this. Or I can keep it the same by not doing anything. And if bit 1 is 1, then I need to have a 0 here, right? But I might decide that I don't want this, right? So rev. So if bit 2 is greater than 0, if bit 1 equals to 0, then I have to do. So let's consider for the very first test case here. So if bit 2 is greater than 0, right? How did I get my answer as 0 here? Okay, so if bit 1 equals to 0, then I can put a 1 here and I can be sure that I'm doing fine, right? And if bit 1 is greater than 0, so I am getting this, right? Okay, so if bit 1 is 0, I want to increase it, right? So I am getting 2 now. Right, so I can have 16 as the answer. Here I can have 8 as the answer. So when I have 4, I have to put a 4, right? Yeah. Yeah, so previous is 4 here. So if the current bit is greater than 0, then I have to do that, right? Yeah, if it is equal to 0, I can either put right, this is one thing, and otherwise I can just leave it like that. Yeah. Okay, so this seems to be fine. Let's submit this. And I hope I'm not calling the brute force method here. Okay, cool. This was a nice problem. Okay, let's look at problem D then. You're given an integer n, find any string s of length n consisting only of English lowercase letters such that each non-empty substring of s occurs in s. Such that each non-empty substring of s occurs in s odd number of times. If there are multiple such strings, output any. It can be shown that such string always exists under the given constraints. Okay, a string A is a substring of B if A can be obtained from A by deletion of several. So can I make sure that every substring that I have is distinct? If I can do that, then I'm done. Obviously, I cannot do that for length greater than 26 here. Because if you talk about substrings of length 1, they would obviously be occurring more than one time. If A can be obtained from B by deletion of, okay. I think this is some constructive algorithm here. So if we look at this one, then BB is occurring thrice. Yeah, A is occurring thrice, A is occurring once. Every substring occurs odd number of times. So for n less than 26, this is fine. Like we can just pick the first 26 letters. I mean the first n letters. N minus 1 minus 1000. I think this can TLE. Not sure. Let me look at the other solutions. I think 200, 300 should be fine, like not more than that. Let me look at the time taken by his code. I don't think we can get that. So even if I consider 1000, I can only have up till 100 of these test cases. What about this solution? He's doing it till 500. Okay, this is one solution that we can try to hack at the end of the contest. Such that each non-empty substring of S occurs in S an odd number of times. So we can definitely not have a periodic string here. If we have a periodic string, then obviously some substring would occur even number of times. Or can we have a periodic string? BBCA, BBBA. It is all about a construction. I mean, if you get the construction, you can just solve the problem really quickly. Let me think about it. Okay, so yeah. So I'm not going to explain the logic here. First of all, let me just code it. Okay. int x equals to n by 2, let's say, y equals to n by 2. Okay, so if n is even, so I want to pick the biggest odd numbers such that if I add them, then the value comes out to be less than n. Let's just do a binary search. I don't have time to think here. So I'm talking about this odd number, right? So if 2 into mid minus 1 is less than equal to n, mid comma answer. So let's just consider a very big number, let's say 1056. So it's coming out to be 527. Yeah, I think we can do this. Okay, but I'm also adding a C here, right? Yeah. So you'll have to figure out for even and odd here. A1 C B1 A2 B2 A1 plus C plus A2 plus B2 plus A2 plus B1. Let's do it for 53. Right, so this is the string here. Okay. It is 51. Okay. What if I had 54 here? Okay. So we have to keep one spare, right? Yeah. So now I have 51. Okay, so we have DEF. Can this number be very small? I don't think so. Let's see 103. Okay, this seems fine. Let's see 104. So I think this should be fine, and if it is already less than 26, then I can just append the first so many characters. Let's do it for 10 here. Because 23 characters are left now, right? Let's do 104 again. So I'm just generating a lot of random numbers here so that I can test it. Okay, 968. I think this should be fine then. Yeah, let's submit this. Okay, cool. So we're done with 4 problems now.